Please join me in welcoming Anand.
Good afternoon, everyone. Thank you so much for the intro. So, today's PPT will be about a journey which I started 2 years back while building the real-time analytics platform at Angel One. Right now, I'm in Tradesea 15 days back, but whatever I will be talking about will be before to that and work that I've done at Angel One. So the journey that started about building the real-time analytics platform lead me to contribute to 4 very significant open source project from Apache Pinot to Roaring Bitmap to Cilium and kernel. Okay, this one next. This is next. Okay. The talk will start with covering the production architecture and how we have built the real-time analytics system. After that, we'll go through the scale at which we are working. Post to that, I have cherry-picked 2 very important or very crucial open source contribution, which we will go through in detail. After that, we will cover the Cilium and kernel contribution, which we started doing last month. So the overall real-time analytics landscape at Angel One used to look like this. So Apache Pinot sits in the middle. It's a OLAP database, very similar to ClickHouse, which a lot of people talked about here. And it's very good in user-facing real-time analytics. I think most of the LinkedIn analytics that you see is powered by Apache Pinot. On the left side, if you see, are the source applications. Source applications like trading applications or KYC, comms, these are the applications. So all these applications stream their event changes related to that event, like order drop happened, order got filled, order close, all this kind of events happen. Similar events happen for KYC and comms or any other domain. So all those domain start ingesting their data into the streaming platform. The streaming platform that we had is two. One is Kafka and the other one is Kinesis. Pinot had the native support to ingest data from both of them. So it ingests data, stores data, have the indexes, table, database, everything in there. Now on the right side, if you see the, okay, sorry. Right side, if you see at the top are the BI dashboards that we have. Some are open source dashboards, some are custom dashboard which we built in-house specific to different domains. Some customer support agents have different dashboards. CXOs have different dashboard. Again, comms have their own dashboards. That and on the bottom, if you see again Navigator, these two are the consumers of the real-time analytics platform. So Navigator is a service that we built in-house to make the real-time analytics platform agnostic of whatever running behind. If we are doing any cluster change tomorrow, or maybe even the whole complete database changes, the user-facing application will not have to worry about that. So it will be just the same API contract for them, and we can do multiple things at the database side, platform changes, anything, so that there is zero downtime for the user-facing applications. And this is the whole architecture landscape. I will not go into the detail because today's motive will be around open source contribution that we have done. The scale that we were handling is around 200K TPS ingestion at peak, 5 million plus queries per day, 5 tenants to avoid the noisy neighbor problem. Whether it is KYC have their own tenant and similar to trade have their own. Some P1 services or critical services had their own, and P3 services were curated into a separate tenant. 20 plus prod tables were running. P99 for the user facing was less than 1900 ms and 19 plus nodes were running. So this is about the scale. Now while we were managing this whole production system and we were building the system around, we could find a lot of issues in the upstream in Apache Pinot. So what we did, we basically started looking at the issues, started reading into the discussions, and then we picked up 2-3 issues and we started raising PR for them. So I will discuss one of our changes in group by queries in Apache Pinot. And to help you understand on a very high level, this is going to be a very simplified version of what I have done. I will attach the QR code in the next slide so that you can scan and go into the detail. So here, if you see the client is there, this is Pinot broker and these are Pinot servers. Pinot servers are nothing but the data nodes. The data of all the tables with different segments sits in this servers. A1 is a segment, A3 is a segment, A2 is a segment, B1. Similarly, all these are segments. One table can have many segments. Order tables can have A1, A2, A3, A4, B1 and B3 as segments. So whenever a client is firing any query, query is basically, again, if you want any insight, analytical insight, top trending stocks in last 1 hour, right? That becomes a SQL query. So client will fire that query. It will go to broker. From broker, it will scatter and gather to different server which have the segments for the table, and then it will aggregate the result and give it back, right? This is how the whole Pinot on a very simplified version works. Now, the contribution that I did is mostly around this queries. One of our custom dashboard had this query, and we started noticing wrong results coming up. Queries with group by but without order by was giving wrong result. And when we deep dive into the code base of Apache Pinot, so we had something that we find out, and that is what I will be talking about. You can scan the QR code to get the PR. Now, whenever someone is firing the query, as I mentioned, it is going to all the servers, and then from servers scatters and gather, return the result. Now, whenever you are sending this query from client to broker, broker to server, server then runs in every segment. So see, segment 1 has written north 10, south 20, east 5, because limit 3 is there. And it then uses concurrent hash map to merge the results that is coming from different segments and then return the results, right? Now, if you see, A1 has north, south, east, A2 returns north, south, west, A3 returns south, north, east. Because limit 3 is there, it runs in every segment, it got the result. What do you think the result will be, right or wrong? So it is going to be wrong. Why it is going to be wrong? Because if you see, east is in A1, east is in A3, but east is not there in A2. But east data could be in A2. But why east data did not came? Because limit is 3 and randomly these 3 keys were picked. And this was not order by, so it went to it started giving wrong result and it was incorrect. So we looked into it. So what we found, the issue is that concurrent hash map. The keys were not shorted. So what we did, we recommended to use concurrent skip list map, which is a Tradesea version of tree map, where the map is shorted by the key. Now, if you see east, north, south, north, south, west, east, north, south. So it's all sorted in alphabetical order. Now A2 does not have east. That means east data is not in that segment. Now whatever result that we will be returning, east 5 and east 25 is the correct result. So this got merged and it is released in Apache Pinot 1.3 version, and it is now getting used across all the companies who have been running Apache Pinot in open source version. While we were doing this contribution, we did some other contribution also into multi-tenancy, security in Pinot. That time we realized one very significant data structure named as roaring bitmap. People have heard about it, roaring bitmaps? Okay, so the roaring bitmap was one such data structure which caught our eye, and we could see some opportunity area or some improvement that can be done in roaring bitmaps. So roaring bitmap is a very important data structure getting used in most of the databases. ClickHouse, Apache Pinot, OpenSearch, and not just databases, into other query engines also. So it is also used in Spark, Hive. So, and the founder and the person who has founded is a professor, Daniel Lemmer, which I will cover in detail in later. But before understanding what our contribution is, it is very necessary to explain the bitmaps, what bitmaps are. So bitmaps are a set representation of an array in bits. So if you see this 3, 7 and 12, and this is the array bits representation, where 3, if it exists, it will be 1, 7 will be 1, 12 will be 1, right? This is the representation. So this is bitmaps, and bitmaps are very helpful in doing AND operation or operation. This kind of operations become very helpful for bitmaps. The reason why is that the CPU is year by year getting very much better at doing SIMD operations, single instruction, multiple data. It's a very underrated thing, by the way. So the way CPUs are improving, the importance of bitmaps and similar data structures are getting very significant. One such example to understand on to have the thought process how it works in a database indexes. If you see, like, where country is equal to n, country is equal to in, these are the row numbers where the data exists, device is equal to mobile, these are the row number that data exist. Now if you want to run this query where country is equal to India and device is equal to mobile, all you do is an AND operation between these two indexes, and you will have the result, the count will be there. Imagine you got the, and this is how OLAP database actually does implement this thing. Without scanning the whole row, you are getting the results so quickly, and hence the latency comes around 200 ms or maybe lesser than that, 100 ms. So this is how the bitmap helps databases implement different kind of solutions. The problem with bitmaps, if you have noticed, these are neighbor data, 137 or 12 13 0. So this is efficient over here, but suppose you have just two values, one is 5 and the other one is 1,000,005. So imagine the amount of space that will be wasted in between with zeros. One is 5 and one is 1,000,005, and all the rest in the between will be 0. So this is not very efficient, right? We cannot use bitmap. So this is where Professor Lemire back in 2017 proposed a data structure named roaring bitmap. He implemented it in C, Java, Go, everything. He published a paper also, and this got adopted in all the databases, and the practical benchmark numbers were very great, very good. And how it works, the roaring bitmaps, it does a partitioning on the most 16 significant digit and then decide, depending on the cardinality, where it store that set in an array, in a bitmap, or in a run length encoding. So run length encoding is a compression where, it basically helps in storing huge amount of data which is very consecutive in a very short form. And similarly, bitmap, as I already explained, an array. So if the cardinality is less, it will store in array. If the cardinality is to some extent, it will store in bitmap, and if the cardinality is very high, it will store in run. So this is how it works, the roaring bitmaps. And now the contribution part will start. What I contributed, I think when I was looking at the code base, there were two type of bitmaps. One is mutable roaring bitmap and one is immutable roaring bitmap. So there was a thread going on between the Pinot's founder Kishore and Daniel Lemire somewhere back in 7 years back. I think they were discussing some implementation around copy on write roaring bitmap. So I somehow I read that thread and I got very interested and started the implementation of it. So why that was required, we'll discuss over here. Now, as I mentioned, there are two type of roaring bitmaps. One is immutable, one is mutable roaring bitmap. Immutable roaring bitmaps are the bitmaps you cannot do any change. So any upsert coming in the OLAP databases and you are going to change the indexes, so you cannot do in a immutable roaring bitmap. Why you cannot do? Immutable roaring bitmap by the name also, and it is stored in disk most likely, backed by memory map. And the mutable roaring bitmap are in memory, where you can make changes, make upsert, you can make any changes, and you can then use it. So what was happening, if you want to make any changes in immutable roaring bitmap, you will have to convert it to mutable roaring bitmap and then you make the change, right? Now when it was converting to immutable roaring bitmap to mutable roaring bitmap, it was copying all the containers even though update came for one container. So it will spike the memory, right? If one change came and you have hundreds of inverted index, and you need to pull all the data in memory and then make changes to all the containers, right? Which was somehow not necessary, but this is a very simplified version. Why it was not implemented is very tricky. So you can scan the QR code and read the PR in detail. I had some email discussion with Professor Lemire also. After that, we came up with the solution here. So what we did, we built a copy on write roaring bitmap. This is what I had implemented back last year. So what we did is basically whatever container that needs to be changed, we will bring when the change is required. We will not touch other containers in the immutable bitmap. And this got merged and is in process. I think that option will happen slowly, but is in process right now. But this PR is merged in the repo, and this is a central repo which is again used by all the databases and query engines. Now while we were doing this change, so my Pinot was running on Kubernetes, and we saw the management and everything very good. So there was an org-wise discussion going on that we will move to Kubernetes completely, the whole infrastructure. Last month, that discussion had started, and then we started evaluating CNI layers and all, and then we also was evaluating Cilium. So while we were evaluating Cilium, we saw some optimization area also in Cilium in the bandwidth manager, and we started raising PRs, and basically PRs got merged. One PR got merged in Cilium. And when we were evaluating Cilium, we read about the outrage that had happened last year in some EU company, where because of some Cilium to kernel expectations were not correct, and it broke the Cilium infrastructure. So that led me to the kernel code, and I started looking at the issues. I raised 4 or 5 PRs into kernel. Three or four are still in review, but one PR got merged in the XDP layer. It's a very small PR, but the ones that I'm working right now in progress, those are going to be significant one. So you can again scan the QR code. You will get the PR, and you can go into detail also. But overall, the journey that has started with Apache Pinot, Roaring Bitmap 2, and Cilium and kernel, this is how the journey looks like. What are the major takeaways? There is always a scope of improvement in any system, even though it is matured with decades or years and years of development. We always can go and do some changes or improve it. So that was one big takeaway. We failed in production. While we were running Pinot, in the first 3-4 months, we failed a lot, and I'm accepting that. And those failure in production actually lead us to start patching in Pinot. The tenancy failure, security failure, group by failures. So all these failures actually give us an opportunity to learn something and then basically contribute back to the upstream. Now, one of the major part on why contribute to open source. So when you contribute to open source, I think you do not get anything in return very quickly. It's not like you will get or save something, but you get to work on weekend. I mean, on Sunday evening, you are working with Apache Pinot Star Tree founder Kishore. Again, on the next Monday morning, you are working with Professor Lemire, who is again a top 2% Stanford scientist. And then the next month you are working with Alexei, kernel score contributor, and the next month again you are working with Hemant Malla. He's a he's a Cilium maintainer. He's one of the core Cilium contributor again. So this you will not get in a company's boundary. So this is what open source provides. You work into multiple things and basically learn from other people, other domains. So yeah, so this is all about. I will continue to contribute to open source to push the ecosystem here in India. So thank you. I think this is all about. Do you want to Q&A?
We are short of time, so I'll